Everyone having a good day so far? What's the word? Yes. Okay, great. Everyone's safe from the storm. It's going pretty bad there for a minute. Had a lemonade popsicle for breakfast. Well, I don't even know where to begin. I was. You were having a good day? Until what? Until this? I'm outside right now. Okay, well, it's not raining anymore, right? I guess that works. Until I turn my camera on without the mask. Yeah. I think I almost fainted in that yesterday, so I beat Megan at archery. Wow. I didn't realize you guys were both archers. That's great. You suck at that. Well, Megan, what's your game? What are you best at? Eight ball or nine ball? Fair. All right, so let's go ahead and start off here with figuring out what is the eccentricity of this ellipse, and not only that, but what the heck does that mean? What can we conclude from that? Well, we ended yesterday with talking about the formula for this is just C divided by A. All right. So I don't need to go through and find my vertices, covertices, foci, etc. Right. This is just asking for the eccentricity. So out of my two denominators, I know that this must be A squared, because A squared is always based on the larger number, which means that A is just the square root of 71. All right, that's not a 71 is not a perfect square, so we'll just leave it as square root of 71. And to figure out what C is, so C we use to find where the foci are. So remember, we have this sort of similar equation to Pythagorean theorem, right? But it's not. It's a squared minus b squared equals c squared. So we have c squared equals 71 minus 36. Okay, and then we're going to want to take the square root of that. So first we'd get c squared equals 35. Then we take the square root. So c is the square root of 35. So let's use these now to find the eccentricity. So we just divide c divided by a. Square root of 35 divided by square root of 71. This is one of the few occasions that we'll actually take a look at a decimal. So square root of 35 divided by square root of 71. And we get 0.7. Right, now, what can we actually get from this? Why is this information useful to me? what does this tell me about the ellipse? So last time we talked about the closer to 1 that is, the more thin the ellipse will be. So thin in either direction. If it's a horizontal ellipse, then thinner this way. If it's a vertical ellipse, thinner, like kind of tall-wise. And if it's closer to 0, then the closer to a circle it is, the more circular. This one we're talking about 0.7, so it's closer to, so it's probably a more thin, a longer ellipse. Longer or thin is kind of in quotation marks. They're not perfect words to describe it. But less looks like a circle. Looks more obviously like an ellipse. Megan is so good at those games, it's crazy. Well, didn't you hear her secret tactic? Just got to eat a lemonade popsicle for breakfast, bro. Then you'll be good to go. Cassidy, don't tell me you forgot to eat your lemonade popsicle this morning. That's embarrassing if so. Lemonade is my strength. And cheese. Well, I'm embarrassed. Yeah, I get it. But at least now you know. Cassidy, how was work last night? Okay, so we're moving on to our next conic section today. So we talked about circles already, which is if we cut the cone straight across. We talked about ellipses, which is if we cut the cone at some sort of angle, right? But we're still going from one side of the cone to the other. And so our next option is, what about if we take a cross-section of the cone that starts through going through one of the sides, but then ends up going through the top as well? Or same thing, but for the bottom. If it goes through a side, but then goes through the bottom of the cone, well, then you can see this shape that is made is a parabola. Karen yelled at Cassie at Target. This one lady was rude and got mad at me because Target was playing rap music. Dang. Well, that was your fault, though, because you hooked up your Spotify to the Target loudspeakers, so you should have seen that one coming. You know. I applied at 7 different jobs. Did you apply at I thought you were going for the freezer section of all the other grocery stores. All Ariana Grande. That's fair. All right, so for a parabola, we're used to thinking about a parabola. We know the parabolas we get from a quadratic. We know that parabola has a vertex. But one of the interesting things about a parabola, we have a different way we can describe it, and sort of a more exact definition. Okay, is that we have sort of these new vocabulary words, which is a directrix and a focus. Focus is part of, we know that ellipses have 2, right? They have foci. A parabola just has one single focus. It has one vertex, and it has a directrix. So a parabola is a set of points equidistant from a point and a line, and that line is the directrix. So let me pull this up really quick. This is not working. I don't know. I don't know what's going on. Never mind. I had a good website I was going to show you, but now it's not loading. Forget it. Okay, but I have it illustrated here, which is this blue point. So if we pick any point on the parabola, so that distance between that point and the focus is the same distance that that point is away from the directrix. I really want this to work for me, but it's not. Oh well. So we're going to introduce this variable called p, and what this represents is it is the distance, so between the focus and the vertex. So that's what this part illustrates right here. Between the focus and the vertex, the distance is p. That's the same distance that happens between the vertex and the directrix. And additionally, it's the distance from the vertex, or sorry, I already said that. We can also see if we start at the focus, that green point in the middle, if we go not just p, but 2p to the right and 2p to the left, that would also give us points on the parabola. All right, so these will be kind of the main points. Those three blue points, and then the vertex and the directrix will be what we use to kind of graph these parabolas from here on out. I just call it a long U. Good point. Here's our equations for the parabolas. All right, we're used to thinking about like the standard form, ax squared plus bx plus c, right? Just a quadratic that would give us a parabola. Or also we have vertex form, which is a times x minus h squared plus k. And so now we have a third form, or forms, which I don't know that there's a specific name for it, but just different ways we can write it. So now that it incorporates this value, this variable p, so that we can know the distance between the focus and the vertex and the directrix. This first equation, so if the squared is around the x value, the x minus h, then this will either be going up or down. If my squared is around the y variable, then this is a parabola that will either be facing left or right. However, for both of these, our same rules of like the vertex is still the same. So our vertex is hk. So we can just look at the x minus h and the y minus k, and that'll immediately tell us where the vertex is. All right, so if the x is being squared, then it's up or down. If the y is being squared, then it's left or right. All All right, and so kind of a nice little, I should have put an actual table here. Let's draw a table for ourselves. So if it's x squared or y squared, now again, the x squared part I just set up there, so it's either up or down, but how do we know that it's going to be up or down? Well, it depends on what the value of p is, okay, if it's positive or negative. So if that p value is positive, then it'll be going up, be concave up. Right, and there's my little focus. However, if the value of p is negative, then it'll be facing down. All right, pretty similar for left and right. If we have a y squared term, so we know it'll be left or right, but if p is positive, it goes right. If it's negative, it goes left. Right, so this is kind of one of those details that makes conic sections difficult, is trying to remember, okay, wait, how do I know specifically if it's up, down, left, right, etc. Okay, so hopefully this little table helps us remember. So let's practice actually taking a conic section and graphing it. Right, how we can go about that from this form, at least this new form that now uses this value, this new variable of lowercase p. This is a reminder to use your pretty pen colors. I always use all my colors. Look at this. Look how colorful this is. What do you mean? Or do you just want me to use pink? Like the pinks and the periwinkle. Okay. Let's start off. Let's start off with pink. Okay. I don't like green and purple together. That's fair. Mostly I just try to use colors that are very distinct from one another. So green and purple, while maybe not the most aesthetically pleasing, they are very easy to distinguish that they're different. Okay, so 8 times y minus 2 equals x plus 1 squared. So if you want, we can rewrite this. See, the problem with the pink and the periwinkle, though, is they're just not very bold colors. You know, like I know that you can see this, but it's just, they're not very distinguished from the screen, you know. They're very softer colors. All right, so since, just looking at this, since I see that it is the x variable that is being squared, I can tell this should be either going up or down. So from here, I just need to determine, okay, what is that value of the lowercase p? So I'm going to look here. So in my equation, in front of that y minus whatever, that's where the 4p should be, right? That's, if I go back to here, so here's my y minus, so the 4p goes right in front of that. So right now my 4 times p is hidden as an 8. So I need to think about, okay, so if 4p is 8, great, then what value of p is it that makes 8, right? Well, this is pretty easy just to do. 4 times 2 is 8, so we can determine that p is 2. So I'm thinking right now, positive value of p, x squared term, so this should be a parabola that's facing up. It's 2. P is 2. Well done, Megan. Vertex, so that's HK, so that would be -1, +2. Okay, and since the value of P is 2, so to find the focus, then I'm going to go up 2. So 1, 2. Remember, if I look back at my pictures here, right, the focus is always sort of on the inside of the curve, right? The focus is, the parabola opens around the focus. So that's why, since I know that my parabola should be opening up, then I know my focus should be up in the middle of that there. Right, and then to determine my directrix, well, my directrix must be in the other direction. So again, since the value of P is 2, so now I'll go down to 1, 2. So that must mean this line is the directrix. Okay, now what is the equation of this line? Well, it is a horizontal line, so horizontal lines are of the form y equals, and the y value for this line is always 0, so y equals 0. Well done again, Megan. Star student today. Well, and every day, of course. All right, and then so I just need a couple other points that will help me determine the shape. This is your best attempt. You're doing great. This is wonderful. Okay, so remember back to our picture. On either side of the focus, if I go 2 times P to the right and 2 times P to the left, that will be where the other 2 points are that I'm going to use. All right, so the value of P is 2. So 2 times 2 is 4. So from my focus, I'm going to go 4 to the right and 4 to the left. Now I can sketch out my parabola. Looks like this. Rain ruined my day. I was going to go on a run. I mean, you could still, it's not raining anymore. You can still go on a run. I know, I love the rain. It was storm this morning. Those are my favorite days. I wish it was cloudy every day and just rained, stormed. That'd be great. Just run inside. Just run. It's not raining. It's done. Gaming weather, man. That's right, gaming weather. So bust out Uno. Okay, go fish, dominoes. All right, next up, Monopoly. Graph the parabola. So again, this is not quite in the form that I like to see it in. It's almost. So I just need to take this +3, move it to the left. So x minus 3 equals -1/4 y plus 2 squared. Where's Ted Bundy fan 23? Megan, we know that that's just your alternate Twitch account is Ted Bundy fan 23. You're watching on your laptop with Mego Lego 5678, and then on your phone you're watching Twitch as Ted Bundy fan 23. If it helps to look at this to compare it to the equations that we had before, right? So for these, the squared part was always on the left side, right? And the singular part was always on the right side. So let's go ahead and fix that. And then in addition to that, I don't want that negative fourth to be on the left. I want, if there's some sort of coefficient being multiplied, I want that to be multiplied by whatever the linear term is. So again, back to the equations. That stuff gets multiplied by whatever the binomial is that has no squared on it. So just y minus k or just the x minus h. So I'll multiply both sides by negative 4. So y plus 2 squared equals negative 4 times x minus 3. And now this is in that ideal form that I can look at this and immediately determine some information to graph it. All right, so let's start with the easy piece, which is the vertex. So 3, negative 2. 1, 2, 3, negative 2. I see that this has the y variable being squared. So that tells me it's either going to go left or right. All right, so I'm just thinking about that. But then I also need to figure out, in order to determine specifically, does it open left, does it open right, I need to figure out what the value of that lowercase p is. So whatever's in front of the linear binomial is it's kind of disguising the 4 times p. So 4 times what would make negative 4? That must mean that p is negative 1. Okay, so since that value is negative, then I know it's going to open to the left. So if I go 1 to the left, that should be where my focus is. So 2, negative 2 is the focus. If I go the other direction, so if I go 1 to the right, then that should be the directrix. So 1 to the right, and then I draw my line. It's the directrix. After that, we just have to, let me write this, directrix. So that equation, it's a vertical line. Vertical lines we know are the form x equals. So this would be x equals 4. Why can't I write 4? There. Once we have those, we just need to find 2 other points. Right, so p is negative 1, so if we go 2 times p in either direction around the focus, but now I'm not going to go left or right from the focus, because since this parabola should be opening to the left, so then I'm going to go up or down from the focus. So 2 times negative 1 is negative 2. All right, so I can go down 2 and up 2. So here's my other 2 points. And I can sketch out my parabola. we're golden. Questions about parabolas or graphing these or the focus, directrix. Conic sections, that PFA, I would say is one of the harder PFAs generally, at least based on students' experience last year. Not because it's so crazy difficult, but there's just lots of very tiny details to remember. Okay, such as remembering how to specifically find, C for an ellipse, or how to find the directrix for a parabola, and what the exact equation is for a parabola, etc. So it's very finicky. There's lots of very tiny details that if even one of them is messed up, then it ruins the whole thing. So just have to be careful. A lot of little things to memorize. Any questions? We're going to talk more about parabolas, but I just wanted to focus on the introducing the equations and then graphing it today, so that tomorrow we can go in and talk about how to look at some characteristics and build our own equations based off of that. No go? Okay. That's all I have for you. I didn't give you a homework assignment or anything. I'll give you a couple of practice problems tomorrow that are graphing and making equations. But other than that, keep requesting PFAs. We've had a good handful that have passed some. So continue that. And let me know if you have any questions. Come in office hours if you need, or email me, and I'll do my best to help you out. Hope you guys have a good rest of your day. Hopefully the weather's nice. You can head outside and take your evening walk with your dogs and family. All right. Thanks for stopping by. See you guys. Can you take a test? Yes.